multiplied x1 and y1 by 4,
Yeah.
do you have to multiply x2 and y2 by 2 as well? Because there's 6. You do, right?
You did it. There should be 2 there.
Yeah.
Good spotting. Yeah. There should be 2 because there are 2 bolts. This is for 1 bolt. This whatever is here is for 1 bolt. This is for 1 bolt. So we have 4 of them, 2 of them. Right? So there should be 2 here and a 2 here. Okay. So that's the so we just simply then find out the resultant. Resultant 87.458. Then try 6 and 28 grade 8.8 bolt. Therefore VFN is equal to 92 greater than V bolt, and it's okay to use. So I chose because I know the demand. Go back to the tables, check against what is the capacity of those bolts and what size we can choose. Then what we did over there, I asked about if we remove 2 bolts, the center row we removed, then what happened? So if I remove the center row, so these 2 bolts are not there anymore. So it's 4 bolts. So it becomes slightly simple. So I have to just rerun the calculation. And rerunning means I just only now have x1 and y1, and sigma x square y square is simply 4 times x1 square y square. This time is correct.
Yeah.
Okay. So 4, and if you put that one, I'll correct it. That will be minor because that's the center row one. So it's a minor difference in the numbers.
Yeah.
So that's become. See, you can see here. This time it's 50,000. Before it was 52,000. So that's only like probably 4%. This only comes to around 4%. So those results will offset by 4%. Whatever the result we have.
Yeah.
So you can see it from here. So fx from the moment is simply that, and then fy from the moment is that. Then I add them. So I need to find out Vx and Vy. So it's simply adding the moment share due to moment and share due to normal or direct share. And then I find out the resultant is 97.673. So before I had 4 and 20, and now the capacity is less than the demand. So the capacity was 92 and the demand is 97 now. Can I use them? No, it doesn't work. So what does that mean? So by removing the row of bolts, the connection will not have adequate capacity to resist the design actions. Below are the 2 recommendations, or 3, sorry, there should be 3 because I given 3. 3 recommendations to increase the capacity of the bolt group. Number 1, increase the number of bolts back to 6. Increase the bolt spacing. By increasing the bolt spacing, what happened? You increase the lever arm. And the lever arm means you reduce the action. So M is equal to F times E. That E is the lever arm. Right? So now F is equal to divided by E. So that is inversely proportional to the lever arm, the forces. If we increase the force, the lever arm, we reduce the force. If we reduce the lever arm, we increase the force. Right? So that's inversely proportional. So that is increase the bolt spacing means we are increasing the lever arm, right? And increase the bolt diameter, another alternative. So that's the end of the question. Question 4. Question 4 was, I think, exactly the same. Sorry, similar. So this time we had laminated floor beams to support 290 by 45 HGA timber floor joists. Floor joists are at 600 centers, provide continuous restraint to the glue laminated beam. Spacing between glue lam is 3 meter. Critical ultimate limit set action 1.2 G plus 1.5 Q. G is equal to 0.4, Q is equal to 5 kPa. Serviceability cases are given. Glue laminated floor beam is simply supported, spanning 4.5 meter above uniformly distributed with the above uniformly distributed actions. Indicative size to start with 450 by 135 GL10. Now what do you have to do? Calculate the design action, check the bending and shear, check adequacy of the beam for short and long-term deflections. I will quickly skip through the model answer, but it's almost the same as the previous year. So again, what do you do? Do the loads, do the moment, do the shear force, then all the data, what do you know, the formula, Zx, and then reduction factor, K1, load duration factor, number of laminates, K6, which is the parallel support factor, LAY, that's between the joists, and because that this time the question said that the joist does provide restraint to the beam. So S is equal to 5.28, K8 is equal to 1, K24 is the formula from table with section 8.7.7, nominal capacity is equal to 67.4 kilonewton, it's okay. Then the shear capacity, the only difference in the shear is the cross-sectional area is 2/3. Then we find out the shear capacity, it's okay. Then deflection, again, we find out the short-term load, the long-term load, everything is given, tributary width is given to you, Q is given, G is given, K2 is given to you. Then you find out the short-term deflection, and then the limit is given to you, compare. Then the long-term deflection, the thing is given to you, and you compare. So it's okay, the section pass. The question 5, but remember this year, it's not the same. There is a timber connection
There is.
as well.
There is.
Yes, there is timber connection. Okay, so there is a timber column. I have mixed and matched timber column, beam, and connections. So all of them are there, but maybe one or another design action is not there. Maybe the bending moment or the shear force, or you just have to do one or another, but rather more. Okay, so be prepared.
Do we have 5 questions? Christian?
Yeah, still the same 5 questions, but maybe like assignment, you have to do connection, you have to do beam, column,
What I
whole
can?
package. Okay, but you will be able to finish it, don't worry.
Cancel.
You sure,
Already
sir?
up, yeah, of
Send me
course.
more money.
Yeah. So, I mean, we did it in 2 hours, 2 examples.
We talked about it.
Huh?
We didn't do it, we talked about it.
Now, how long did it take to do the connection questions last week? How many questions we did last session? 4. We did 4 questions last Wednesday. Yeah. 4 questions we did.
Tuesday.
Wednesday.
Oh, sorry, Wednesday.
Tuesday was no class. Okay, so the 5th question is,
transfer the
again,
timber
this time it's a
from
post,
mistake.
but it's the
Yes,
only
but
difference is
this
weight
gets
condition.
for today's lunch.
And the size.
5, so it's like
And it's
4
supporting,
from my
the
side.
height is 3 meter between floors, pin at the base and supporting 10 square meter flooring. The top of the column is connected to 2 beams with steel Bomek brackets and running at right angle to each other. The connection provides strength to the column in both directions. Both directions, that means something. The beam in x-axis is supported on the edge of the column and apply eccentric load to the top of the column with eccentricity of 90 millimeter. G is equal to 0.5, Q is equal to 3, 1.2 G plus 1.5, Q, that's the load that you need to use. Eccentricity is given in EY, there is nothing. Check the adequacy of the column for bending and compression. And then the last one, check the adequacy of the column for combined bending and compression. Okay, so again, G is given, Q is given, we have to calculate the axial load using the formula, you should know that. Then eccentricity, then eccentric, what is the moment applied by that load? This time it's 4.59, it's quite huge because of that small eccentricity increase. 90 millimeter, it looks small, but it is a lot. Make sure when you side fixing a beam to a column, especially in timber, it's getting quite critical. Make sure you do this check, otherwise, it could fail. Especially, the external structures, because of the moisture condition, the capacities are dropped. So, then the moment capacity, there is nothing new, exactly the same thing. The only thing is we have to use the FB for weight condition this time. So, it's right here, 11.7, and FC is equal to 12 this time. Because of the wet condition, it drops from 18 to 12, so that means 33% reduction in compression strength. Again, it's a square section, so you will get the S value of 0, and therefore K8 will be equal to 1. Mn is equal to that, 8.27, so the moment capacity is okay. I have to move on. Again, I got a square section, so NCX is equal to NCY. That is, it should be NCY rather than NYX, it should be NCY. I do mistakes, typo errors. It's not basically a typo error, right? As you don't know, like, I mean, when you sit the whole day on a computer and then come home and again sit on the computer, you get really blurry vision. And I'll tell you something. You know, I look young, but I got lots of problems. My first problem is, with this eye, I hardly can see you. Number one problem. Back 7 years ago, 8 years ago, when my second daughter was born, we came from the hospital and I told my wife, you know, everything I look at is too bright. I can't, you know, when I go out, I get this tearing and things. So I went to the doctor. So we just came from the hospital and I went to the GP. And the GP looked at my eyes and he straight away sent me to the eye clinic. And in the eye clinic, I was waiting there for 3 or 4 hours and they straight sent me to the ward. The eye ward, and admittedly, they say you can't go home. Oh God, what happened now? We will tell you. It's a long story. There is some problem with your eyes and anything can happen and your eye can bleed and it can totally, you can get blind.
Blow up?
Man, that was the longest night of my life, you know, to wait for the morning, to send me to Auckland Hospital from Greenland, to do the CT scan of the eye, back of the eye, and make sure that it was the unreactive eye pupil. So the black of your eyes, what happened, it worked like a camera lens at focus. You know, when it's light, it gets smaller. When it's dark, it gets bigger, so you can see, right? So when they did so that thing was not reacting to light. My eye pupil, it was big and stay all the time big. It was not reacting to the light. The good one, not the bad one. So what happened when they did the CT scan the next day, and then they put me back in the ambulance, back to Greenland, and then over there, like I was waiting for the doctor, and he came in the evening. The next day in the evening, and my wife was waiting at home, where I gone, you know, I just rang that I can't come. And she was worried as well because I just admitted, so she, but I thought it's big problem. So then what happened when the doctor come in the evening, he said, oh, because there is a viral infection or something could have happened and that blocked your nerve and you have to live with this problem. So now, like, when I look at something for long, it's get blurry, so I have to close my eyes and then again look. So then it's that, you know, that vision problem. So, and 4 of my discs at my back, they are degenerated. So I got quite bad back and knees arthritis, and winter I'm quite, you know, even in the class, I don't know whether I told you, if I collapse, don't worry. You know, just before I tried, I don't know whether you notice, I hold here. I was going through that episode. You know, like this year I'm quite good, but last year, at least twice a fortnight, I collapse. I can't hold myself. It's too much shooting pain in my back, and I just can't hold. And I have to hold something, and I slowly stretch and straighten my back. You know, so don't worry. That's something. So life is beautiful. Okay. So whatever you have, be thankful. Okay. So, well, I don't know why I said this. There was something behind something I started the story. So, let's say K8, we found out the NCX. NCX turns out to be 209, too much, and it's okay. We move on to the next, and then the combined chip comes to 79%, and it's okay. That's the end of the question. And the end of the exam 2018. Now questions. It's all yours. Now you ask me what you want to ask me, or